My friend picked the headphone stand I almost threw away. He'd asked me to make him one of these, the Grumpy Goose, hundreds of dollars, always sold out, and I had never carved a thing in my life. I grabbed some walnut off the rack, grabbed a power carver, and started making mistakes.
This sucks.
Stick around to see how the biggest mistake of this build became the reason he loved it. Here are the headphone stands my friend wanted. The Grumpy Goose headphone stand. They're made by Chris O'Neill in Canada. They're beautiful, and they're always sold out. So when my friend heard I was a closet woodworker, he asked me if I would build him some headphone stands. When he showed me the pictures, I was fairly certain I could never make something that looked like that. I had never seen anything like that and really had never even seen any YouTube videos of anyone building anything like it. So the answer in my head was no. My ego slowly became attached to the identity of the guy who can make things, and so the project begins. There are 3 major challenges with this project. 1. How do I make the flowing gooseneck shape? 2. How can I do the joinery, leaving the minimum amount of wood left to shape? 3. How can I get all the pieces to flow together into the shapes I need? Now, if you've never tried to match the shape of the curved object in 3D modeling, here's a great tip. If you have a photo of the image, you can actually paste that directly into your software. Then you can use the spline tool, clicking along the curve, and the software will smooth out the curve between all the points you click. Just click enough points to match the shape, and you'll end up with a pretty good match to the photo. I used this approach on the curves all along the neck, and I assumed 3/4 stock to get the dimensions on the other pieces. And altogether I ended up with this partial model of the headphone stand. I cut it into 3 pieces, printed it out, and CA glued it together. I have the model. It gives me a good idea of the dimensions of all these pieces, so I can use it to set up the width of certain cuts. I can use it to mark the length of different wood. I can use it to mark curves on the wood so I can waste the least amount of wood. I'm pretty sure with this I won't make any mistakes. I don't know about you, but when I took a look at Chris's headphone stands, the first thing I thought was, how the heck does that thing stay together? Most people would look at that and think you just glue some pieces of wood together. Unfortunately, that approach will result in someone's $900 headphones falling to the floor. The problem is grain direction. The neck runs vertically, the head and base run horizontally. So wood glue, which barely sticks to the end grain in the first place, is being asked to hold the 2 most important joints in the whole piece. So I'm putting dominoes at each end of the neck. But strength isn't actually the hard point, making it square is. If the mortises in the neck are off by even a degree or 2, the joints will be twisted, and your eye would catch that instantly. Joints twisted out of square will result in the goose looking like it doesn't want to talk to you anymore. So the question I'm dealing with is, how do I drop a mortise on the exact center line of the base, perfectly square, 3 times? So here's the base plate. We need to get a domino directly on this center line. It's just like sitting here in space. So what we're gonna do is take advantage of the fact that the distance between the base of the domino and the center line of the cut is always exactly 10 millimeters. So what we can do is make a fence so that the distance between the center and the fence is that 10 millimeters. In other words, if we just put that right there, so that it would be centered, and then we have a fence right here, so there's something to push this up against, then we know it'll be right there. So we need a fence like this right here. So what we're gonna do is take this and get it glued on right there. So the width of that block is 51 millimeters. So half of that is 25.5. And then the 10 millimeters for the domino offset leaves us 14.5 millimeters. So if we just get the distance of the overhang to be 14.5 millimeters, it'll be the right distance. I have a pro tip if you need to get two pieces of wood to stick together with an offset like I need for this fence. Use these setup blocks, which you can get on Amazon for cheaper than the Red Tool Company, link in the description. Lock the fence of your table saw down for a super sturdy 90-degree stop block. Push everything tight up against the fence as you do the next steps. Put your spacers for the offset you need, then put your bottom piece up against the spacers. Put some CA glue on the bottom piece, and then hold everything tight. There's no need to use accelerator here, and it can actually get you into trouble if you're not quick enough, so just hold it for 10 seconds or so, and it will all stay together. I made 5 major mistakes on this project. This is the first one. I hadn't used my domino in a while and forgot to check the tightness setting. I blew the mortise right out the back of the bottom of this piece. Scribble, 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 click, 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 swoop. When I was in school for engineering, one of the things they trained us to do was write down our assumptions, even ones that seem obvious. Atmospheric pressure, room temperature, steel is perfectly elastic, this kind of thing. One of the benefits of this is it teaches us to avoid making incorrect implicit assumptions. Implicit assumptions are ones you make without realizing you're making them. In other words, it trains you to stop and think if there's something you're not thinking about before you get someone killed. Or in this case, placing a mortise right out the back of the top of the neck and the head of a goose-shaped headphone stand. You see, I made an implicit assumption when aligning the domino centers, that the wood that was there when I lined them up would still be there after I finished cutting the shape of the neck. This was not a good assumption. The problem is that while the bottom of the neck connects to the base and stays vertical, the top of the neck flows into the curve of the head in a sweeping motion. So while the mortises are hidden in both the neck and the head when they're made, they're both exposed after the shaping. At this point, I had 3 options. 1. Leave the dominoes exposed. Dominoes are made from beech, which is very light, so that's a choice, but not one I was going to make. 2. Start over on the 3 necks. This would actually be not that difficult because at this point they are basically just rectangles. But I decided to go with option 3. Make my own dominoes out of walnut and try to match the grain so that it would not be that noticeable. Making your own dominoes is not something you only need to use for fixing mistakes. You can make exposed domino joinery on purpose, potentially using contrasting color wood like in this video from Sedge Tool. I'm using wood from the same board to make domino stock, basically really long dominoes. To round the corners, you can use a roundover bit and make 4 cuts, or a special domino profile bit and make 2 cuts. I didn't have either of these bits in the right size, so I used a hand plane to manually put a roundish profile. At this point, the basic joinery is complete, but before I actually glue it together, there's a lot of shaping I can do while it's still in 3 pieces. This is when things got hard. Earlier, I had formed the rough shape of the head by gluing 2 blocks of wood together with a little offset based on the 3D printed model, which gave me the width of the rips and the offset for the curve at the back of the neck. This clip shows the head is actually a lot wider than I realized from the still images, but unfortunately I didn't find these videos until later. But when my friend said he needed the top to be sanded down to be round, I thought, I'll show him sanded down. Anyway, here's another pro tip from a non-pro. Use 3D printing to create templates. Revolutionary, right? But it's not what you think. The head has this curved profile over the top, where I want the very top to be kind of flat and the sides to be pretty vertical. It's kind of like Tim Apple's rounded corners, but a little more rounded than that. Like that. Now I don't have an 8-inch template bit to run around this template, so I'm going old school. Block plane. Shape the template so that it fits snugly on the ends of the piece. Using that, draw the shape of the profile on both sides. Then use the block plane to cut chamfers close to your line. Chamfer? Chamfer?
Chamfer.
Chamfer. Then cut the points of the chamfers to make more chamfers. If you make enough chamfers, the chamfers disappear, just like holes and puddles. A trip to the bandsaw, and I have the head as far as I want to get it before glue up. Fresh off my pencil templating victory with the head, I decided to continue with this approach on the base. We have these 3 profiles on the base. Instead of making the template cover the whole piece, I instead added little notches to mark the center line for aligning them on the work. My hope was that I could simply bandsaw this right along the line and then clean it up a little bit. But I vastly overestimated my bandsawing ability and the ability of the bandsaw to make these tight curves. So I tried my new power carving bits to clean up the curves and other saw marks. The first profile I did took me a while to figure out, but by the last one I had a system and was getting the cleanup done in a few minutes each. I printed out a second copy of the neck here. I printed it thinner just so that it would print faster. I don't like the quality of this print. It looks like it landed on some poop. Also, the spline is not very smooth here just because that's the way Shaper 3D does splines. So what I'm going to do is just put it on some of this 1/2-inch MDF and then I can smooth it out with the sander. I'm using double-sided tape to connect the printed template to the MDF here and then to the workpiece. I used to hate dealing with double-sided tape because I'd always have so much trouble getting the paper off of the tape. But then I found out that if you just peel the paper up once you already have the tape on the work and cut the tape without cutting the paper, it's a lot easier. You just have to cut the excess paper off every once in a while. Actually, hold on, I think the game is coming on.
And we are back on WSN, the Woodshop Network, broadcasting live from a high-stakes garage in Kirkland where the tension is palpable. Dave is stepping up to the router table looking to force a heavily curved template layout directly against a 20,000 RPM spinning blade of death. Dave, what do you like about his positioning here?
Well, Dave, I like the equipment. That is a top-tier, highly expensive router table setup. Incredible horsepower. Unfortunately, the guy operating it is a weekend warrior, but he has all the confidence of a guy who refuses to read the IKEA instructions because he, quote, knows how dowels work.
That's right, Dave. I was actually talking to Dave down on the bench before the game, and he told me he has extreme confidence in his template routing strategy today. He said since he was removing most of the waste with the bandsaw, he likes...
Oh man, look at that. A giant piece of the neck just flew right off into the router fence. Oh, look at the instant replay. Oh my God, look at the size of that chunk that's just gone.
That's right, and the problem here is that at the top of the neck, the grain is really short. There's actually only a few millimeters or less than an inch of grain that's actually holding each of the pieces of wood at the top of the neck there. You really got to be careful when you get to the top.
Let me stop you right there. It looks like Dave is going with the exact same approach. And he's got some shatter, but he's just going back in for more. He's going. Oh my God, same problem. He just went for it again, and the same exact thing happened. Does this guy learn anything?
I don't know, Dave, and the crowd in Kirkland is they're perplexed. And let's just see if we can get a better look at this instant replay to see what kind of damage we have to the top of the neck here. Oh, there you see it. There's just a chunk of wood flying right up off the top of the neck. Absolute carnage all over the router table as pieces of the neck are flying everywhere, hitting the fence. Going back in for the third and final neck. Looks like he's trying to make sure the template is firmly attached to the wood.
Yeah, Dave, I don't think a firm connection with the template's going to save him here. He really needs to figure out his technique.
That's right, Dave. To avoid this, he really needs to flip the piece upside down and come up at it.
The crowd reacting here to some pretty bad shatter Dave's getting already.
That's right, he's going with the same technique. He's pushing it through. Oh, a piece is already flying out. Chips flying everywhere. Oh my God, look at the size of that chunk that has just flown off the top of the neck.
That's a huge piece, Dave. I've seen guys make bowls with less wood than that.
It's just everywhere. The carnage is undeniable.
And another undeniable fact, Dave, that man has not changed a single thing about his approach today. Not one thing.
It's a total blowout. That piece is at least 3/8 of an inch.
Dave, that goose is cooked.
It sure is, Dave. So there you have it. Final score. The Walnut 3, Dave 0. Dominant performance from the Walnut today. Folks, I'm Dave. He's Dave. Good night from Kirkland. It's okay. We'll fix it in post. Remember those custom dominoes that fit perfectly? Once they had some glue on them, swelling the wood, the fit was no longer perfect. Some of these glue-ups were a bit touch and go and required some persuasion to come together. And some of the joints refused to come together fully, leaving cracks at the joint. In my experience, there are a lot of reasons that we procrastinate, all rooted in fear of something. But let's focus on one that I experienced while building these headphone stands. Once this thing was glued together and it was time to carve it into beautiful goose-shaped curves, whenever I had time to go into the shop, I would find a reason not to. I'm too tired. I don't even really want to make this thing. I need new equipment for making the video. I should be working on this other thing I want to do. But one unthought thought was always, I don't know how to do this carving. I even said as much on camera right before the glue up. The thing I'm most nervous about is trying to figure out how to blend in the neck here to the base. Well, I'm also nervous about how I'm going to get this to curve up. But yeah, time to glue it up. But somehow, later, this thought was not coming into my brain. I only had this feeling of resistance. I was left only with a subconscious feeling of being nervous and... This sucks. I don't know how to make the curve go right. Maybe it'll go right. We'll see what happens. Now, as boys, we were conditioned that the only acceptable emotions to express are anger and triumph. So this feeling of fear was completely suppressed for me when it was time to do the carving. The way this worked for me was, this new thing seems hard, plus fear of failure, which is completely invisible, equals we're too tired to do this. This went on for weeks. Eventually, I started to carve. Let me share 4 tips I learned. These are tips from a complete noob at power carving. If you have any others, please leave them in the comments for everyone. 1. Remove as much waste as you can with a saw. I used a pull saw to cut off the back of the head and a fret saw to create the shape towards the front of the beak. 2. Use a coarse grind to get close to the final shape. Hold the grinder very steady with 2 hands to avoid digging into adjacent surfaces. 3. Get to a finished surface by using fine carving bits, power sanders with soft pads, and hand sanding. Finesse the surface as much as possible with the fine bits so that the sanding doesn't take as much time. Don't be afraid to go back to a grindy bit to take some off if the sanding is taking too long. 4. For super tight inside curves, you can use a sanding drum and a rotary tool to limit hand sanding. How did I go from procrastination to progress? The best way is probably to realize what you are afraid of and either stop being afraid of it or begin while afraid. In this case, I used a far less reliable method. Overcome the fear of failure with a bigger fear. I was making 2 of these for a friend, and it had been a while since I started, and really, I just didn't want to be seen as unreliable. I overcame my fear of failure with the fear of being unreliable. And it turns out that carving was actually fun. It's very forgiving. Material is only slowly removed, and you can adjust based on which bits you're using. You can kind of remove material to fix mistakes. It turns out I was afraid for so long for nothing. One thing I've learned about being afraid of starting, or failing, or whatever it is keeping you from accomplishing your dreams, being afraid of whatever it is, and suffering from perfectionism, is that you will never feel ready. You can't think your way to confidence. The only way to feel ready, to be ready, is to actually do it, to actually make the thing. And with the carving done, we've completed our final challenge. Now before we get the finish on, I need to deal with the gaps in the joinery. These headphone stands are going on a friend's desk, my first build for someone outside of my family, and every time he looks at them, I don't want him thinking about what went wrong. I want him to enjoy his music. The gaps come from 2 places. Some were at the joints themselves. The custom dominoes swelled with glue and prevented some of those pieces from closing all the way under the clamps. And the others were caused by the domino mortises being too deep compared to the domino itself. This is always the case with dominoes, but normally you don't see the mortise after the assembly is done. Thanks to my mistake on mortise placement, we have exposed mortises at the top of all 3 necks. So how are we going to fix this? The first option is black CA glue or epoxy. You work it into the gap, let it cure, scrape off the excess, and sand it smooth. This is fast and easy. It's not going to disappear, those gaps are too big for that, but black CA glue and walnut has a way of looking like it belongs. Your brain just sees it as dark, and that fits in with the walnut. The second option is to repair it with real wood. You cut off some small pieces from the original board, match the grain as closely as you can, and then you glue them in, pair it flush with a chisel, and sand it down. This takes longer than the glue, but when it works, the grain runs right across the joint, and you would never know it was there. I tried it both ways across the 3 pieces. I'd love to hear what you think looks best down in the comments. So with all the gaps fixed, I put a coat of Rubio Monocoat and walnut on, and got ready to show them to my friend. I just wasn't sure which headphone stand he would like best. So here they are, 3 headphone stands. Each one started from the same board of walnut, same 3D printed template, same dominoes, Same power carving that stopped my progress for weeks, but they didn't end up the same. Here's the first one. This is the one where the mistakes are most hidden. The gaps in the joints, I patched those with wood and they just disappear. Look as close as you want, you would never know I made a mistake on it. The second one. This is the one I filled with black CA glue, so there's a dark line running right through the joint. This is the one where the poorly fitting joinery shows the most. On the other two, the wood patches mostly vanished. Here, the fix is accented, not hidden. And the third one. This is the one where I forgot to check the tightness setting and blew the mortise straight through the back. So now you can see the custom domino right at the base of the neck. It was never supposed to show. This mistake I couldn't hide. Now here's the thing. Looking at them, you can't even tell which ones had the biggest tear out from routing the necks. All that panic, all that "this sucks" energy, it's invisible now. Three headphone stands, but my friend only asked for 2, so he has to pick the ones he wants. Now if you asked me which one I would have picked, I would have said the first one, no question. The wood patches disappear into the grain. It's the closest thing to no mistakes were made. And I figured that's what you want when someone builds something for you. You want it to look like they nailed it. The first stand he picked was stand 2, the one with the dark glue line running along the joint. I remember thinking that's the one where the poorly fitting joinery was most obvious. I had done it the harder way on the other two, matching the wood grain, and they looked better. He said the dark line gave it character. And then he picked the third one, number 3, the one with the exposed mortise at the base of the neck, the actual mistake. The one I kept thinking I should have started over on, should have relaid out the dominoes, should have done it right. But here's what I couldn't see because I was so fixated on my mistake. The open mortise at the base mirrors the exposed joint at the top of the neck. It creates this symmetry that I never intended. I saw the mistake as a huge failure. He saw it as a design element. He chose the 2 most flawed pieces. He skipped the one that I thought was closest to perfect. I spent weeks afraid of ruining these. I avoided the shop. I told myself I wasn't ready. And the pieces my friend loved most, the ones that he uses every day, are the ones with the most visible evidence of everything I got wrong. It turns out not perfect can still be great, especially to someone who never thought it was possible in the first place.